Hello everyone, I'm 𝐶𝐻, a developer relations engineer here at 𝐊𝐚, and I will be your host for the workshop on Speed Up Your App Development and Test Journey with GitHub and HyperExecute. In this workshop, we will explore vital Git features, staging, commits, branching, and more. We will discover end-to-end web development workflows, including code creation, testing, GitHub integrations. We will also be looking into how to run tests with GitHub, triggering them via actions, and orchestrating through Lambda Test HyperExecute, our blazing end-to-end test orchestration cloud. Now, before we begin, I want to highlight a few things. This session is being recorded, so in case you need to drop off midway and you need to watch it later on, the sessions will be entirely available in Testmu event. Just go on to the view schedule section and click on watch it. We will also be sharing these recordings over YouTube channel by the end of the week. We will be having a dedicated Q&A round towards the end, so feel free to address any questions during the session in the Q&A window on the top right side of the screen. You can react to the session by expressing your reactions through the emojis on the bottom of the screen. You can also show your love and support to the speakers of the workshop as well. Having said that, join me in welcoming our speakers, Karan and Divya. Karan is an influential leader in GitHub's international developer relations. He aims to empower every developer within the open source ecosystem with Git and GitHub Actions. Divya is leading Microsoft Azure Core apps and digital innovation portfolio at Microsoft Technology Center, India. She helps driving adoption across areas like generative AI and building AI-first intelligence apps on cloud. Hi, Karan. Hi, Divya. How are you doing?
Hi, Sparsh.
Hi, Sparsh.
Doing good. Thank you.
Thank you. Thank you for this workshop. I really look forward for this workshop that it's going to be promising, enlightening, and enjoyable. Now, everyone, please welcome Karan and Divya. Hi.
Hi, everyone. Thanks a lot for joining. All right. Sparsh, shall we kick off?
Yeah, it's all good.
Okay, great. Let me bring up my screen. All right. So I hope my screen is visible.
Yes, Karan, it's visible.
Great. Hello, everyone, and thanks for joining in, wherever you're joining in from today. For this workshop on where we're going to be talking more around speeding up your app development and your testing journey with GitHub and HyperExecute. So I know Sparsh gave a good introduction. Thanks a lot for that, Sparsh. However, again, a quick hello. I'm Karan, and I take care of international developer relations here at GitHub, which means I basically work with a whole lot of developers, open source ecosystem, enterprises, startups, academia, and a whole lot of other people, and help them in their journey on GitHub and open source. All right, now before we get started with this workshop over the next course of 90 minutes, right? There are two things that I really want to know from all of you, just to get a understanding of your expectations or ideas of the things that you would want to take away, so that we can, we can spend some more time on that. So for that, I have two polls which Sparsh is going to help me bring up right now. First is just to know your idea of version control itself when it comes to your work in QA. So if you can just take a few seconds and then vote on the poll that you see on your screen right now, and share what is your familiarity with version control, mainly Git. And yes, please feel free to keep this session interactive and put in all of the questions. I see a couple of you have already shared questions, so thanks for that. If there's anything else that comes along, please feel free to put in your questions there as well. All right. Can we bring up the next poll, please, Sparsh, if enough folks have voted on it? All right, so you would see another poll coming your way right now. It will be helpful if you can just again take a few seconds to share your familiarity with GitHub Actions itself. It's okay even if you haven't heard about it, or if you know it in and out. It'd be really useful if you can just take a few seconds to share your familiarity with it. So while some of you might be voting on the polls, say a quick hello in the chat and share where you are joining it from today for this workshop. All right, so I think if we have enough folks, we could probably close the polls first. I think we can also close the first poll around version control. Okay, great. Thanks everyone for sharing it. So we have a mixed audience out over here today who kind of know a bit about the version control, use it, as well as similarity with GitHub Actions as well. So over the course of next 50 minutes or so, I'll take you through some of the basics of version control very quickly, and also dive into some of the collaboration and also the automation aspects on GitHub Actions. As Sparsh also mentioned, feel free to share any of the questions that you have in Q&A. So for those of you who are very new to version control or for Git itself, right? I want to take a few minutes to just really talk about version control itself for those of you who are very new to it. So just imagine that you're probably writing a script, for automating certain test cases, all right? And probably you're doing it in Selenium or in Python or any of the various other tools that are available for scripting. So say for this example, you create a script.python, all right, .py in Python for your test observation. And then you would have to make a change. Say, there's some logic error or something else that you had to add. And how would you do it if there was no version control? One, I'm sure you would want to at least say whatever is available existing so that you can go back to it. And at the same time, probably create a new copy and version of it, right? So you create one more script-2 or script-new.py or something else. And again, if you want to iterate on top of that, you would again go on and create a new script-3.py or something like that, right? And then you want to make a change again, and so on and so on and so on, right? So you see, soon all of this is going to start getting so very messy with just various different versions of the same file existing wherever you are saving this. And one day, you'll also start wondering, like, okay, which is supposed to be the latest one? Is it just the script, or is it script/4, or which is even the last one? But what essentially all of this here it's happening is that all of this is the same script, with just incremental changes over time, and that's where version control really comes into play. So, in very very simple terms, to those of you who are very new to version control, think of it as just a way to save changes over time without overwriting previous versions. All right. So you almost have like all of your changes and snapshots over time so that you can go back in time. One of the only places where you can probably do so, if not in real life. And then look at what was there previously and then also move forward. All right. So in very, very simple terms, what is version control? Yeah. Now, naturally, when it comes to version control, the most popular version control that you might hear of is Git. Now, I know you might be thinking, and most often many people ask me this as to what's the difference between Git and GitHub? Isn't it the same? And most often people refer GitHub as Git and Git as GitHub, etc. So let me clear that first upfront itself. That Git is a distributed version control software. All right. So what I spoke about right now for a couple of minutes, the version control aspect, Git is an example of such a similar version control software that's distributed. Okay, which means multiple folks can work on it together at the same time. Whereas coming to GitHub is a platform, all right, where you can really build, scale, and deliver secure software, an entire developer platform powered by AI with multiple aspects. Where you can build for scale, have security as a part of your development, help you be more productive, collaborate with your team members, and also powered by AI, along with a whole lot of integrations and APIs. Okay, so Git is a version control software, whereas GitHub is an entire developer platform. Okay. All right. So I know that was a very, very quick overview of version control, which many of you might already be aware of. But one of the things that whenever I'm talking to people in the QA community, I was like, why is this even important for QA? All right. Now, I'm sure most of you might know, but I want to give you a quick overview of why is this really important for QA? Why you even have to think about or care about version control? Now, a few key things that that you can really think about. One is you can really keep all of your test cases alongside the code, which helps you really know what's the expected behavior of the code, along with of course the test case. And also, you can really roll back all of your test suite along with the code. So it really helps both your test cases and the code that it helps test in a single place together. The second thing is also you can review all of your tests using your usual code review processes itself. So you might have, of course, come across this if there's any feature development that's happening. Each organization, each team might have their own code review processes, right? So having your test cases and test suites, in version control alongside your code can help make sure that the processes that are there for reviewing all of the test cases is similar to the functionality and the feature code as well. And of course, what I mentioned, the other interesting thing is that it also acts almost like a log of how test cases change over time. And typically, one of the things that many organizations use this for is to track the progress of coverage. So initially, when you start off, probably you had like 30, 40, 70, 80%, or whatever is the coverage that you started off with. And over time, when you're maintaining that, right, and if you're kind of exporting all of the test coverage reports somewhere and then looking at it where it's tagged to a version control, you'll be really able to track what is the coverage like or what is the QA quality like, and all of those metrics, whatever you deem important. And of course, the major thing is really helps you shift left, which means you can really help test early and test much more often and stay much more close in sync with the functionality and the code aspect itself. So again, all solid reasons, and most organizations today have their test automation scripts and their entire test suites version control alongside the code itself. Okay, so all right, what's version control? Done. Why version control? Yes. And also, spent a couple of minutes talking about the fundamentals of Git and the what is Git. So, but let's take a few more minutes for those of you who are again new for version control to talk about what is this Git and the GitHub flow, which you might encounter a lot. So let's take a few minutes looking into what is this Git, what are some of the key things to keep in mind when you are using Git version control, and then also the GitHub flow itself of how things really work on GitHub. Now, don't worry, I'm going to be showing you a demo of all of this, including my further slides, but just want to establish a few base concepts so that we can go into the demos in a much more easier way. So a few key terminologies, just things that you would have to remember when it comes to Git version control, and a couple of terminologies specific to GitHub as well. Very first thing you would hear a lot is repository, aka repo in short. So it's basically just a collection of files as well as the history of changes and any other metadata. So an analogy is that think of it almost as a folder, but it's not just the current state of the files, it also has the history of the changes and any other associated metadata like messages, descriptions, etc., which I'll talk about. So second thing is commit, all right? Something that you hear very, very often. So commit is a snapshot of your entire repository in time. So in your repository, if there are certain files and you create a commit, you're essentially creating a snapshot. And then say after a few more changes, you're creating another commit. It means you're creating another snapshot. The next thing is branch. Now, branch is, there are two ways that you can think about it. One is it's a very lightweight mobile pointer to a commit. You can say that, this is where my branch starts, and this is how all of, my commits are kind of organized together. But if you were to think about it, your way of how you generally work, think of it as, work streams, various different work streams of how you might want to do. For example, if you have, your main work stream where there is, where you're kind of really, where all of your, say, DevOps team or even, your own development team is deploying code. And then on the other side, you might probably be having another work stream where there's a feature development happening. And on another work stream, you might be having your own test automations being written, right? So how do you work on all of these multiple files and multiple code in a way that you don't cross over each other, but at some point you would want to bring everything together, but you still need the independence of being able to work by yourself, right? So that's the concept of branches. And yes, it's almost very similar to how you might think of as branches of a tree where there is a trunk and there are multiple branches coming off from the trunk, and then branches from branches, etc. Right? So just keep that analogy in mind. It's going to be helpful. And the next thing is around pull request, what you would very, very often hear abbreviated as PR. Now, again, two ways to think about pull request. Okay. Now, firstly, think of pull request as a place to compare and discuss differences introduced in a branch. All right. Now, I'll give you an example. Say there is one branch where your engineering team, your development team is building the app functionality, all right? And there is one other branch where you're writing all of the test automation and your test suite for that specific app functionality, all right? So branch name is, say, a feature A, and then you're writing one more branch where you're continuously committing code, which can be named as, say, test suite A, all right? Now, you would want all of your test suite code in test suite branch A to be pulled into the feature A, all right, so that the feature can be shipped. So what you're doing is you're requesting that it be pulled from your specific branch to some other branch. So that's a pull request, okay? And it's also a conversation view on GitHub where you'll be able to compare and discuss the differences and comment, etc., which I show in the demo. And the other thing that you would hear often is clone, all right? Now, if you're a Star Wars fan like me, you might be thinking of Clone Wars. There's no wars over here, but the clone is essentially a local version of a repository in your development machine or anywhere else, which includes all of the commits, which means all of the snapshots of your repository and the branches as well. So that it's a local version where you can move back and forth in time, go back to an old commit, work on your existing branch, work on a new branch, etc. And the last thing is a remote. Okay. Now, a remote is, think of it often as a common repository on GitHub that can be used to exchange changes. Now, if there are multiple people, if there are 5 of you, 10 of you, which is often the case, right? And you are working on your own local version repositories, the clones, and you would want to somehow synchronize everything. That's where a place like a remote, like a GitHub repository, would come into place, so that you can push and pull changes as and when needed, and merge changes as well into your local version repository. So again, a little bit more on that in a bit of a while. So these are some of the basics. There are, of course, a ton of other Git commands that are there for various different kinds of operations, but these basics should be enough for you to just understand how everything works. All right, great. So let's move on to the next one, which is, how does this all come together? What's the relation between a commit and a branch? What's the relation between, say, a branch and a pull request? Or what's the relation between a repository and a pull request, etc.? Right? How does this all come together? What is the flow like? And that's where something like the GitHub flow comes into play. Okay, so in GitHub, and when you're working on it, you would see often one has the main work stream, all right, as the master branch, or it's often called as the default branch or the main branch or whatever else it is. Basically, one continuous main default development branch. And whenever you want to start something from it as a starting point, you create a new branch. So in this example, you're creating a feature branch from master from a specific instance of time. All right. And you're saying that, okay, I want all of the changes in this specific instance of time, and I want to start a new branch, a new work stream from that. And then that's where you start to commit the changes. So you probably take that snapshot of time with whatever changes are there, make some more changes, etc., and then commit them. Okay. And once you've committed the changes, now if you remember, what you'd want to do, and ideally in the end, is you would want these changes to be a part of the main default branch, right? Because maybe that is what is being shipped. So what you do is you submit a pull request, okay? And on the pull request is where there can be discussions on the proposed changes, make more commits if you need, etc., have an approval workflow, and all of those things. And once that pull request has been approved, those changes can be merged, what you see in the last, where the feature branch can be merged into the master branch, right? So that's when all of the changes get brought over into the default branch. So enough of talking about Git and GitHub flow. So let's quickly take a look at this in action and see how all of this really comes together. So for that, I'm gonna switch over my screen quickly for a minute so I can bring in my demo to showcase you how all of this would come together. So let me open up this, and with the demo that I'm about to show you, this is something that you can try it out yourself as well on your own GitHub repository. So, all right. So this is GitHub skills. If you go on skills.github.com, you can see there are multiple courses which help you guide how to use multiple aspects of GitHub. So let's start with just the first one. If you're doing it by yourself, it takes you less than an hour, but I'm gonna show this to you in 5 minutes because I've already introduced all of the concepts to you. Okay. Now the way to get started is start this course, and I'm gonna open it up in a new tab. And this is going to create a new repository under the account not Karan. I don't know who that is. With the name of the repository, Skills Introduction to GitHub, and it's going to be a public repository, which means anyone can see it, or even you can make it private if you wish so. So here, just because for the sake of demo and for learning, I'm going to be creating a public repository for us to take a look at how this whole of the flow really looks like. Now, if you're very, very new to the GitHub interface, this is what a repository page on GitHub looks like, where you can see all of the files over here and the contents of this special file called readme.md, .md for Markdown, where it shows you the content of the file. And you can see the pull request over here that I spoke about. There are no pull requests over here. So we'll see that once we create a pull request. So with skills.github.com, all you have to do is just take a look at readme.md and take the steps and actions that it indicates to you, and you'll be able to move forward. So you can see the basics of what I spoke to you about, what is the repository, what's a branch, etc. What is GitHub. The first step it says is create a branch, and then let's see how to go about it. And it gives you information of how to accomplish each of the steps to complete the task. Okay, so here you can see all of the branches. We are on the main branch, what I told you, the default branch. So let's create a new branch, and let me take a look at the instruction. Here it says create the name as my first branch. I'm just going to create a branch over here named my first branch. Now what it's going to do is it's going to take whatever was current on the main branch and then create a new branch called my first branch. So if you see here, there are two branches now. One is the main branch and one is the my first branch. Now the nice thing about learning with skills.github.com is it automatically updates the instructions when you refresh a page. It could take a few seconds, but here you see step one, you created a branch. Now you need to work on it. You need to make some changes, right? You need to commit something. So here it is. There are some instructions that it gives you. It's telling you to create a new file called profile.md. So what I'm going to do is I am going to create a duplicate of this so I can follow along here and see the instructions here. Okay. All right. So it says add a new file and create a new file named profile.md. And here is the content. So you can see there is also an inbuilt editor over here, and there is also a possibility to open up a complete IDE as well within GitHub. if you just press on the dot key. So if you're interested, just open up any of your repository on GitHub and just enter the dot key. Your full ID is going to come up. So anyway, so there is a welcome to my GitHub profile, and then I commit the changes here using the screen button. Sorry, I think the specific screen that I'm sharing is not visible. So let me just reshare the entire screen so you're able to see it more clearly. And all right. So I created profile.empty and then also entered this text, welcome to my GitHub profile, and I can even see the preview of it. And using the screen button here, I can commit the changes, create a message, whatever I want. By default, it's create whatever is the file name, and then commit directly to the my first branch. All right. So when I say commit the changes would get committed. And when I go back into the code, you can see here that my first branches, on that branch, the profile.md file is there. But if I switch over to the main branch, there is no profile.md because you've just committed the changes, but we haven't created any pull request to really bring over those changes, right? So we have completed this step. So let's give it a few seconds to see what GitHub Skills tells us to do next. All right, so you can see the next step is open a pull request. So you made a change, and now you would want to bring those pull requests into the main branch. All right, and it tells you multiple different ways of how to create the pull request. And you can either go to comparing pull request here that you see on top, or you can just go to pull request, say new pull request, and then you define that you want to bring the changes from my first branch into the main branch. All right, it tells you what all commits will be moved over to the main branch, and here you can see the example profile.md, which was what we had created. So we're just going to say create pull request and add my first file, which I think is what the instruction was at my first file. All right. And then I'm gonna hit on create a pull request. I can add a description here, just er and single file. All right, and create a pull request. So here you can see a conversation thread that started where people can come in and then share any comments on this. They can look at what were the files that got changed, and like directly add comments as well, however they want, and even approve any of the changes here by going to review changes, approve, request changes, comment, etc. All right. So that's the pull request, where we open a pull request and then say these are the changes. And finally it says, well, that's good. Let's go ahead and merge the pull request. So when I hit here on merge pull request, what it's going to do is bring over all of the changes from my first branch into the main branch. So if we go back into the code, here you can see there is main branch and my first branch. And in the main branch, we can see that profile.empty has now come in, which means what we have done so far is we have successfully created a new branch, added some of our changes, created a pull request, and then also merged that pull request into the main branch. All right. So this is some of the basics of the collaboration. So let me switch over back to my slides to move forward to talk a little bit more around how we can automate some of these things and where do we kind of head next. So let me bring up my screen. Meanwhile, if you have any questions, feel free to share them in the Q&A part. So let me share my screen once again. All right. So that's where we landed up with a demo. So let's move on to how you can automate with GitHub Actions and what is that all about. So for that, let's take a few minutes to really know about what is this GitHub Actions. All right. Now let me give you a scenario. Think about, say, you have to create a task or a conversation thread, or how it's called as an issue with a capital I on GitHub, and you would want it to be labeled as soon as it's created. Or if there is a push that happens, which means you're sending over code to the remote, and then you want a build to happen for that. Or there is a pull request that gets created, and an automatic comment has to be added. Now, if there are any of these things which are repetitive, right, most probably there is maybe even a person, who is really sitting and doing all of these things, which is very, very repetitive, right? That's where something like GitHub Actions can come into play, helping you automate various different things. Now, before I move on, I'd like to tell you that GitHub Actions is free for public repositories and has certain limits for private repositories, and there are multiple other tiers plans available for enterprises and organizations. A lot more powerful control also available. But for you, if you want to just get started personally and try out, it's free on public repositories. All right. So what are these actions? Now, think of these as standalone reusable components that can perform a certain task. Now, there are three ways how this can happen. One is you get this action from the GitHub Marketplace on github.com/marketplace, which is open source actions that people would have created and published. Or you can write a shell script, or you can write your own action using Node 16 or Docker. So let's see how all of this really fits into one of the scenarios that I spoke about, which is when there is a commit, or say when there is a push, you want to build to occur, which is very typical in your CI/CD pipelines, right? So let's break this apart. We know we want to start with a push and a CI, and we want to end up with a build. And the main thing that really connects all of this is something called as the workflow file, which defines all of the instructions on how this needs to happen. Now, for this workflow file, it needs an event that needs to be triggered. So in this case, the event is a push or a commit, which triggers the workflow file. And the workflow file makes use of the actions, which could be from a marketplace or the shell script or your own actions, which I mentioned, takes all of those with certain amount of customization, along with your code if need be, and then runs them on virtual machines. Why? To perform the specific task that you need, which in this case, to create a build, all right? And this whole thing is what GitHub Actions is, including all of those individual standalone reusable components, the workflow file, and the virtual machines, etc. And if you have to generalize this, if there is any event that needs to be triggered, the workflow file takes all of these standalone components that you define, runs them on runners, which could be virtual machines or even Docker containers. And these runners could be, either on the GitHub cloud, or even you can self-host it to perform certain tasks. All right. Now, as you can see here, the heartbeat of how all of GitHub Actions works is really the workflow file. So what are really these workflows? So before I go on to the demo, I want to cover a bit about these workflows so I can show you in action, no pun intended, how actions works. So workflows are simply just YAML files in a special directory in the repository, which lives in .github/workflows. So So that defines all of the automated procedures. So it's a simple YAML file, the workflow file. All right. Now, what does a workflow file look like? It includes all of the things which I mentioned about, but let's take a very, very brief overview of a basic structure of a workflow file, which will make it very, very easy and simple for you to use these workflows or build your own workflows. Now, the first thing is the workflow file defines the events. If you remember, we defined push as an event. Here you can see pull request as an example, or a manually running the workflow as an example. So it defines the triggers of what should make this workflow file run. What should kick off the workflow? It could be one or more triggers, and it will be qualified as needed. For example, push only to main or so, and it can run for specific branches, or you can even schedule it with a cron, and you can even trigger manually if need be. All right. So there's an event section that is preceded by the on keyword. Next comes the jobs. All right. Now, what are these? These are basically the set of steps that execute on the same runner. In this case, here you see build as an example. The name of the job is called build, and all of the steps execute on the same runner. And each of the jobs, if there are multiple jobs, run in their own virtual machine, and they run in parallel to the other jobs unless they're specified otherwise. And next is the runner. All right. Now you define the runner, which is basically where you're telling which is the server that has GitHub Actions runner app installed. That's the runner. So in this case here we say Ubuntu latest, which means whichever is the server which has the latest Ubuntu and the GitHub Actions runner app installed, run all of these automations there. Now this runner, like how I mentioned, can be self-hosted by you on your own virtual machines as well if you want. And there are multiple different sizes, etc. And what the runner does is it listens for all of the available jobs, runs once at a time, and reports back the progress, logs, and results. And like how I mentioned, this can be hosted by GitHub or the GitHub Cloud, or it can be self-hosted by you as well. And finally, the GitHub hosted runners are based on Ubuntu Linux, Microsoft Windows, and macOS. So you can choose whichever you want if you want to do multiple builds, etc. So we define the triggers, we define the job, we define the runner where we need, and next comes the actual steps. So these are the actual individual tasks that runs commands in a specific job. And this can be an action or a shell command. So you can see here, the first one using the checkout action is from the marketplace. The next one is a shell script. The next one is a multi-line script. And the last one could be your own action. So it could be a combination of anything, basically a procedural stepwise list. And all of these steps in a job execute on the same runner. So that's about it. That's a very, very complete basic workflow that can be run, which defines the triggers, which defines the jobs, the runner, and steps. Now, a really, really very useful thing with GitHub Actions is that it has live logs. So as and when an action workflow file is running, it's going to stream all of the logs with deep links, so you can take a look at what's happening. So it helps provide you rich feedback into the progress of your workflow files, say in this case a build. They're also even formatted for easy reading. You can kind of look into and dive into it. And also you can really deep link to any line, any log with a really clean and simple permalink as well. And there's also a really nice visualization that's there. So if there are multiple dependencies between jobs, etc., you can understand all of the workflows and track the progress in real time to see how all of these run together. So I know that was a lot about actions and workflow files. So let's take 5 minutes to see a demo of how all of this really works. So for that, let me go back to my demo screen and come back to GitHub skills so I can show you how all of this works as well. So coming back to my GitHub screen. So let's quickly take a look at this course called Test with Actions, where we're going to write a very simple linting test to see how you can use actions. So as usual, I'm going to start off this course over here by creating a new repository called Skills Test with Actions, which is public, and wait for a few seconds. While this is loading up, I want to also show you the marketplace, where you can see a whole lot of GitHub actions, and that's where you can use actions of Lambda test as well. For example, there's a really nice tunnel action where you can really run some of your tests using the Selenium grid by tunneling it to Selenium grid. So that's an example that you can check out as well with all of the ways. So, but let's come back to this once we get an idea. All right. So here is the course that's ready for me, and like how I mentioned, there's a workflow, a job, a step, and an action. Let's just add a test workflow to really start with. All right, and I already covered all of these things. And it says start with a simple workflow named 𝐶𝐈.YAML. So how we can get that started is you go into the actions tab here on the top. And here on the left, you say a new workflow. And based on your repository, there could be multiple options that are suggested as well, customized to your code. All of these are again available on the marketplace. So here I'm going to start off with a simple workflow and say configure. So you can see the structure is very similar. There's an on trigger, and then there's a jobs, there's a build, there's a runs on, and all of these. Right? So let's go back to our instructions in the course, and it says remove all the steps other than the checkout step, and use this for linting the markdown. So here there are 3 steps. First is the checkout, and I'm going to remove both of these and just paste this. Since it's YAML, you would have to make sure the indentation is correct. Otherwise, you can see it's going to give you a bit of trouble. As with any other YAML. All right. So we've done that, and if you recollect, we would have to commit the changes. But before that, we would have to actually create a new branch named CI, which we hadn't created. But not to worry, we can create that while committing itself. The important part is just making sure. Now, these are all not hard set standards. You can choose whatever you want, but we're just doing it for the sake of this tutorial. So I'm going to say commit the changes, and I can create a new branch right from here named CI. So it's a new work stream that I want to work on. And once that's done, I can say it's a new linting action and create a pull request. Okay. So what we've done is now created a simple workflow and then added this run. So this runs within the shell of the GitHub runner. It installs the action for linting, and then from npm, and then it runs remark. All right. So let's hit on refresh and then see. Great. Now it says fix the test. All right. Now you can see that actions would have run here. When you go into the actions tab, you can see multiple actions that could have run. And here is the workflow run, where there is a failed workflow file, and the build job failed. So let's see what happened over here. So the step of our markdown field linting has failed, which means, as an example, some test has failed. And here in the logs, I can see that there is a markdown called resume.md, and on line 9, the emphasis should use an underscore as a marker. All right, interesting. So let's go back into our code. Make sure we are on the CI branch because that's where we are working on. And let's see resume.md. Let's edit this file over here. And on line 9, there it is. So instead of the asterisk, it should be using underscore. And there's a nice tip here. It says, yep, you found the error. So let's go ahead and fix that and replace the asterisk with underscore and commit those changes by updating it to the CI branch. So now we have done that. And then let's see, we've identified the test which has failed, fixed the test, and pushed it as well. So we need to wait for a few seconds once those changes have been detected in the tutorial so that it can update with the next steps of how to proceed. Great. So here it is. And then it says, upload now the test reports. All right. And there is, again, one other GitHub action that can help you upload the artifacts for, for the specific job that you have, and then save it as well. And then, you can download it using download artifact. So what it says is use this specific action/upload artifact to go ahead and upload it. So let's go back again to our CI branch and change the workflow file, like I mentioned, .github/workflows, and ci.yaml is where we have created it. Let's go ahead and edit this, and in the end, add a new action to upload the artifact. Okay, I'm gonna make sure the indentation is right for YAML, and going to go ahead and commit this to the CI branch. All right. So you can see whenever all of these happen, it triggers a new action workflow for uploading the test reports, etc., and other things. All right, which gets queued and then which gets progressed. And at the same time, you can take a look at the live logs. So let's refresh and then see what's coming up. All right, it says, okay, great job uploading the test reports. And you can actually see that when there are artifacts that get uploaded. All right, the final thing it says is to add branch protections to make sure that all of these tests run, or rather protect from any other changes so that it's not pushed. All right, so I'll show you what that happens is you can protect your main branch to make sure that a pull request is required before merging, and multiple other protections, and to make sure that the status checks must pass before merging. All right, so it enforces this, and in your world, it can really help you make sure that that whatever you're working on can actually be enforced in terms of test results or anything else, to make sure that inadvertently people don't push something. So let's go back into pull requests and then see what it says over here. And here it says that, well, everything is good to go, and that has been enforced. And finally, it says, well, we are actually good to go ahead and merge this pull request right now. All right. So very, very simple demo and an example. And what I showed you overall has been, we created a very simple workflow to just check out the code from our repository And then after that, we have added a simple workflow, did some small linting, uploaded the artifact, and then done. All right. So again, a very simple example. You can go back into skills.github.com to check it out, and you will check out lambda test tunnel action. Similarly, here it mentions the steps that you need to use, start the tunnel, and for example, run your tests, and then upload the artifacts, etc. Right? So that's something that you can check it out and go back to skills.github.com if you want to explore some more advanced topics around how everything else works when it comes to GitHub Actions and a whole lot more. So in the last 5 minutes now, before we dive a little bit more into HyperExecute and also AI, I want to give a very quick overview of how AI can really help with all of this. So just give me a moment while I bring up my presentation screen back. All right. Okay, great. So the last thing is how AI can really help. And on GitHub, we have GitHub Copilot, which is an AI-powered pair programmer which can help you with multiple different things. But before that, what is GitHub Copilot? All right. And like how I mentioned, Copilot is an AI pair programmer that helps you write code, tests, anything that's faster and with less work. Now, I want to emphasize the phrase AI pair programmer because it's not something that can do everything on itself for you. It acts more as a pair programmer to write your test suites and your automations that's needed, along with your own specific judgment and intent of how you want to move ahead. So is it really magic of how it works? Well, not really. Like how I mentioned, it cannot read minds, although it sometimes feels like it can. But by sharing really code completion suggestions based on the context of the file and style conventions, etc., GitHub Copilot can really increase, the velocity and confidence as a test engineer, as a QA engineer, as a developer, or anyone who is in this development. So, like I mentioned, if it's not magic, then what is it? So fundamentally, GitHub Copilot draws context from comments in code and suggests individual lines and even whole functions instantly. So it's powered by OpenAI Codex, the one which is available right now, and it's an OpenAI model that translates natural language into code. So how this works is like how I mentioned. Within your IDE, be it VS Code, Visual Studio, 𝐂𝐕, JetBrains IDEs, etc., it provides the context to Copilot, and Copilot uses the OpenAI Codex model and returns suggestions to your editor, where you can choose whether to accept it or ignore it, etc. So it provides context only from local files that's open in your editor, so it's not attached to a repository. And the data that it shares is very, very ephemeral. So it's shared with GitHub Copilot only just as long as it's enough for Copilot to provide a suggestion. And I really want to emphasize is that we do not take that code and put it back into the data model for suggestions or even store it. It's there only as long as it's needed for the context to generate the suggestions. So what are the features of GitHub Copilot, or how can you really use? Now, there is one very, very exciting feature which Divya will showcase to you in a while, but the core features of it is it helps you really convert comments to code. So as you can see as an example, if you just give it a comment, it can help return an entire code function or a line of function. It can help you autofill some of the repetitive code, especially when it's needed for you from a testing perspective for edge cases, or for when you know that there's going to be repetitive code, you can really autofill that easily. And it can even give you a whole lot of alternative solutions which you can use as provided or edit as per your needs. So again, here is an example that one of my colleague had recorded a while ago, where you give it a prompt, say validate a phone number, and you can see all of that being generated, where it creates a regex pattern, and then also automatically suggests that, okay, this is how you go ahead and log it, etc. Right? Very, very basic example, but a lot of different use cases for it. And again, GitHub Copilot can be available to you as an individual, but also to your business with Copilot for Business, where organizations can manage licenses and policy from a central location using your existing GitHub organizations. And with that also comes a whole lot of controls, where as an individual user, or even as a business, you can say that, okay, I don't want any public code suggestions, and you have that choice to enable that filter during setup on your individual accounts, or for businesses, the enterprise administrator can set it up as well. If you're thinking how do you install this, how do you use it, how do you get started, it's very, very simple. In Visual Studio Code, it's available as an extension that you can just install and log into GitHub, provided that you have the subscription to GitHub Copilot that you have purchased already or your business has provided you. Similarly, with Visual Studio as well, you can get it as an extension. What are benefits of this? You might be thinking. Now, it's left to you how you really want to use the power of AI. But there are a couple of things, and the main thing is really that it helps boost productivity. And any productivity, when I say developer, it doesn't mean just someone who's working on the app functionality. It could even be a test engineer, or it could even be a DevOps engineer, or anyone else. It really helps boost the productivity by giving you an autocomplete a whole lot of suggestions. Very less context switching, because you wouldn't have to go and keep on going around finding and searching on a search engine how to do that or how to do this. You can just give it a comment, and then it can help you give a whole lot of suggestions. And in fact, using one of our own research and findings, we saw that developers and engineers using GitHub Copilot have seen 88% faster completion, a lot of less mental effort on repetitive tasks, spend less time searching, stay more in the flow on whatever they're working on, are more fulfilled with their job, and are very much less frustrated when coding, because you can look at multiple different alternative suggestions on how to implement it. And like how I mentioned, what this really, really impacts is the confidence, the morale, and the performance, which is the psychological safety as well of how you want to use it for your work. And it's not just us telling about this. There is a whole lot of sentiment and feedback from users as well. For example, and more developers who are using GitHub Copilot, and amongst those who are using it and using it with Python, we've seen that almost 40% of the code they say was actually synthesized by GitHub Copilot. And in a very another similar interesting study that we had, where we asked two groups of developers and gave them a very similar task, we saw that those who use GitHub Copilot were able to not just complete it, but also complete it 55% faster than the group who didn't. So all of this is available on the GitHub site and GitHub blog as well, but that's something that really, really helps. A whole lot of examples that are there as well, how people are using it. For example, there are people who are using it for pattern recognition. Here in the case, write something in English and then you want it to be translated in different languages. Um, People who are using it to write code snippets in docs or even docs themselves. People who are using it for various different ways of how AI can help in their work. But again, underlying part is GitHub Copilot can really help you brainstorm, think about ideas when you reach a mental block, jog your memory on how you want it to work for you, and then really retain focus instead of leaving your editor. You can stay in the flow. All right, now I know that was a ton of things that I mentioned about with Copilot. I know you're excited to know about Copilot in action and then also how you can use Copilot and GitHub Actions with HyperExecute as well. So with that, I'd like to hand over to Divya, who's going to show you a lot more demo around Copilot, GitHub Actions, and HyperExecute as well. So if you have any questions, we can take it up towards the end of the session once Divya is done, and I'm happy to answer them asynchronously as well for you. So over to you, Divya.
Thank you, Karan. Thank you for setting the context for today's session. I'll right away jump into demos because I think as developers, all of us like to see things in action, right? So I'm going to quickly share my screen and let's get into see how we can actually put these tools into action or into perspective, right? So what I've done here is I have my Visual Studio Code, which is the IDE that I use, and I'm actually looking at developing a full stack application over here, right? I have a React.js application, which is my front end. And then I also have, and as a developer, I would need to write test scripts. I would need to do a lot of things, right? Now, what if I had a tool or an AI assistant that can help me to actually do this job much faster? And that's what GitHub Copilot is for us, right? I do have the advanced version of GitHub Copilot, which is called Copilot X. And within the Copilot X family, I have something called as GitHub Copilot Chat, where I can actually chat and start writing code. So how do I do that, right? So like Karan mentioned earlier, all I would need to do is go and install this extension on my IDE. It's a very simple process. So I go to my IDE, and as you can see, there are a bunch of plugins that are available on the IDEs, and I have already installed the Copilot Chat plugin. The GitHub Copilot is the feature which will help you to have auto suggestions based on the code that you have. Copilot Chat is the advanced feature where you get a chat like interface that you can actually converse with the code and start synthesizing new code, right? So I have already installed this, and once you install, you get an interface like this, as you can see. And I can type in pretty much what I want to do here. So I would say this takes coding for developers to the next level. So let's say, for example, I have inherited a particular piece of code, right? And I don't know what this particular code does. Can I ask Copilot some help on this? So can I say, can you please explain this code, right? So let me start with, first of all, understanding what the code does. So it basically beautifully gives me an explanation of what this code is actually doing. Now let's say I'm not happy with the code that's written here, and I don't see exception handling, I don't see error handling. So can I ask Copilot to do that? So can I say, add validations and exception handling, for example, right? Now, as a developer, typically what do? We go to public sites. We try and figure out, what is the mechanism through which I can add a validation for the particular function, or I want to do an exception handling for the particular function. But as you can see, Copilot automatically gave me the entire code, and all I would need to do is take this and insert it at the cursor, and automatically this code becomes part of my repository, right? So this is as simple as it can be. Now let's say, I have a scenario where I want to go back and I say, create comments for this code, right? Because maybe I want to generate comments, I want to put in the code, and I want the next developer who's actually taking on this code to basically not struggle, right? So I say create comment for this code, and it'll help me to generate the comments. So as you can see, this is the agent that actually helps in getting us the code suggestions based on the question that we ask Copilot to do. So I've got the comment generated, and now I can say, copy paste this to the editor. I can either do a copy paste or I can insert in line, and it automatically starts reflecting. But the beauty is, the whole funda of generative AI, we're looking at a natural language construct where I'm just speaking to the assistant, and the assistant is actually able to understand my intent, and given my context, it's also able to give me a meaningful suggestion or code. Now let's say I have the code written, right? What next? So typically for developers, what do we do is, let's say I say, create test cases for this code, right? I have highlighted a particular snippet of code, and now I say create the necessary test cases for this. So as you can see, it is churning out lines and lines of code in a matter of a few seconds, and you might have also observed that it handles multiple scenarios, right? What if I have a valid input? What if it's an invalid input? And multiple such scenarios. And if at all, pretty much it is still going on, it is also giving me a little bit of test data, the relevant asset statements that I would need to make. So for this very small snippet of code, it has actually synthesized 8 different scenarios for me in terms of test cases. And all I would need to now do is, let's say, I take this, I insert into a new file, and this becomes a utility for me to author my test cases, right? So it is not just helping you with the code, it is also helping you with synthesizing the test cases. Now, let's say, for example, I have a scenario where I have a particular programming language. I want to convert this from one programming language to the other. I have a SQL code here, and I say, I will convert this code into, let's say, Java, right? So typically, if you're working on a migration project, you're trying to transform some bit of data or the code that resides in the stored prop, and you might actually want to get it to the application layer, right? And people would have to actually rewrite. So here, if you can see, automatically it gave me a Java version of the particular stored prop. Now, there could be scenarios where the Copilot may not get the code 100% right, but that's where we would need to intervene, and we would need to give specific suggestions to Copilot in the sense, let's say I say, add exception handling, name the method in a particular manner, or I would say method one does this, method two does this, generate the code for this. So we need to be as prescriptive as we can so that we get the relevant output, right? So this is yet another functionality. So you could have multiple such scenarios where you're looking at design patterns, or you might want to generate an automation script. So let's say I say, create a deployment script, right, to deploy a Java app to Linux, let's say, right? And typically we end up doing a lot of automation. So you could give a specific scenario. You could also write the code, the pseudo code, I would say, right, or the logic or the algorithm that actually powers the code that you would need. So once you give this input in English, the English like construct actually gets converted into code. And as you can see, it created a very beautiful script for me. And this is all done in a matter of a few seconds. This is not a recorded demo. I'm doing it live on my IDE as we speak. And it takes the context of the code that I've selected, or it also takes the context of the open files in my IDE, and basis that context, it understands whether it's a React.js app, it's a Node.js app, or whatnot, right? And then it is able to give me suggestions. So pretty much Copilot understands most of the recent popular languages and frameworks, because it has been trained on the world's corpus of text and code. The underlying models which power Copilot, these have been trained on the world's corpus of text and code, and it understands the code that's available in the public domain, and then it starts synthesizing the new code for you. It's not a copy paste version. It basically takes your context, and with that context as input, it starts synthesizing the code for you. And then it's up to you to kind of accept that code or ask for more suggestions on top of the code that it's already giving, so that you get a better and a performant code. So, like I said earlier, pretty much most of the popular programming languages and framework are already supported by Copilot. Now, let's switch gears, right? And we'll see an example of how I could look at a particular website. So, this is a website that I'm trying to develop, let's say, right? And it has a lot of features, and I'm a developer. I'm given a task to basically modify something in the website, and I would actually need to complete my testing, my unit testing, my integration testing. Also, my build pipeline should work, right? So, this is a standard use case in the life of a developer every single day. So, what if I had a tool like like Copilot as well as HyperExecute? So this is where I'm going to introduce to you HyperExecute. We saw what Copilot can offer to us. We'll switch gears and we look at what HyperExecute actually means. HyperExecute is actually new gen test execution or orchestration framework, which will help you to very seamlessly execute test cases on the cloud. And it can help you to execute test cases across different form factors, across different platforms. Concurrent executions are possible. So you typically build a test suite with a whole lot of test cases that you want to execute. You define a configuration of how the test cases need to be basically identified. So you could either specify it as a config file, or you could also enable auto discovery. So the moment hyper execute, so there's a hyperexecute.yaml, which basically takes the test cases as the input, and it then uses the infrastructure on cloud to run these test cases and give you a report, right? That's what basically HyperExecute does. So I would say it is the next gen test orchestration platform, which will give you not just test orchestration, but also analytics, insights, reporting, and a lot more additional features when it comes to testing across various platforms, across various form factors, etc. Right? Now, I showed you an example of the website that I'm trying to create, and let's say I'm tasked to add a new feature, and I'm rolling out feature, let's say an offer for Independence Day, for example, right? So there's an Independence Day coming up, and I'm trying to roll out offers for Independence Day. And I go ahead and I modify the code, and I actually add this particular code into my UI layer, right? So this is my UI layer. Now let's say I come back and I would need to add a backend layer or an API layer here. So I'll switch to Copilot. I'll say, hey Copilot, can you create a function to get new offers, right? So it should ideally take the context of this page and help me to create a function which will help me get the new or the latest offers that I would have, right? So it automatically gave me a function. It says, get new offers. What I would do here is I'll go ahead and I will insert this at the cursor, and automatically the code gets inserted at the cursor, and I can go about it. So now I've made changes to my UI layer, made changes to my API layer, and now I will have to end up writing test cases, right? So I come back here and I say, okay, now I've got a new feature. Now I'll have to write a equivalent test case for that feature, and I'll say create test case to validate a new message with text right? So let's say this is the text or the input that I'm going to give to Copilot. So Copilot automatically gets the context of this page and it says, hey, look, this is the new test case that you might want to create. So I just take this test case, I copy paste it here, and this automatically becomes part of my test suite. Now, yes, now I've completed my coding, I've completed my testing. What next? So I have all of this in my version control. So you might have heard in the earlier session in terms of how you will create a Git repository. So my entire code base is now part of a Git repository. I would need to commit this file. So I will basically look at all the files that I have changed. I will save them first, and I will basically look at how I can go ahead and commit the file. So I there's something called a staging where I'll identify which are the files that I would ideally want to commit. So I will stage my files first, and I'm using a GitHub plugin within the Visual Studio ecosystem, which will help me to automatically use the GUI for doing the commits rather than doing a CLI commit. Now I say added new feature for ID, for example, right? So this is a new feature and I just do a commit and a push. So when I do a commit and a push, I commit to the local repository as well as I push it to the remote so that any other developer who is also collaborating with me on the same project will basically have access to the latest files. Now, as you can see, it got committed, and how this is done is through my workflow file. So this is basically my GitHub workflow file, and I have my job, and within the job I have something called as GitHub actions. My first action talks about checkout of the file, and the second action actually talks about triggering the execution of the bunch of test cases that I have identified via HyperExecute, right? So this is a means in which I'm actually on the runtime where I'm actually going ahead and downloading the code. I will be able to download the HyperExecute CLI and invoke the HyperExecute CLI from there so that it then triggers a remote execution on the HyperExecute platform. So let's see how this is done, right? So I will switch over to my browser and I will probably go ahead and check whether the GitHub action has been triggered or not, because the moment I committed, ideally it should have triggered the GitHub action. Yes, so look here, automatically it has started the build because this was part of my workflow, this was the job that is defined, and as part of my build I can go ahead and see or double click into what is the action that's happening, and I can get a live log of whether the checkout has happened, whether the CLI testing has occurred, and so on, so right. So this is a means through which I've automatically through Copilot, I have synthesized my code, I have synthesized my test cases, and I've committed it into my feature branch, and automatically it triggers the GitHub workflow. And now it has actually submitted a job to HyperExecute, which is a an agnostic platform where you will get the job that's already triggered by the system, right? So let me just refresh my screen. It should have ideally submitted a job for execution. So while I wait for that, as you can see, this is the job that's been created. I just had a recent run in the interest of time. So I just did a run a few minutes ago, and let me walk you through how the whole thing worked, right? So basically, it took each of the test files, because I had given a particular way or a format in which the test cases were discovered. So these are all the entire bunch of test cases that I had, and these were part of my execution suite. And as you can see, the all these test cases have been executed. Now this is a platform where your test cases will be pushed, and your test cases will be, and you can also define scenarios or configurations in which you can execute these test cases concurrently. So so there is another question in chat which I saw, which says, what are the platforms that basically HyperExecute supports, right? There are a bunch of platforms that HyperExecute supports in terms of the most popular frameworks and languages, as you can see on the screen. Pretty much in terms of Python or C or any of the popular programming languages, the frameworks that are out there in the public, pretty much all of these programming languages are supported by HyperExecute. So you could use these new gen tools to trigger deployments and to actually make your work faster. So that's one aspect of it. The second aspect of it that I would like to showcase to you is, let's say I don't have a GitHub workflow, but I have done a local test. Right now, let me come back here, and I have my code here, and I'm trying to look at adding a new test case. Again, I reach out to my friend, which is Copilot chat, and I say maybe uh, add a test case to verify the, I would say, to verify the platform, or verify the the browser header, for example, right? If let's say this is my test case, and I go ahead and ask Copilot to synthesize a test case for me, so automatically it goes ahead and it adds an equivalent test case for me, which I could use here, and I can then say this is my test case. Let's go ahead and execute this, right? I can then say verify browser header. Yep. So this is Copilot in the auto suggest mode. So I accept what it gives. Now, if I were to submit a job, right, I could actually do it from my from the HyperExecute CLI on the machine that I'm working on. If I've not yet created my GitHub workflow, but I want to execute this job on from my workstation, I can actually have the HyperExecute exe. I can also use the HyperExecute YAML, which will basically define the configurations where how do I identify the test cases, what are the necessary artifacts, what are the pre-steps, what are the post-steps. So I can pretty much configure all of this in my YAML file. I can give that YAML file as the input, and with the help of a few credentials which are available as a to you as a user, I can kickstart an execution of HyperExecute, and automatically this job should be visible to me in a while on the HyperExecute platform. So once the job is submitted here, then automatically I will be able to see new version, or I would say a new execution that will have to be triggered basis the submission of my job. So let me just go ahead and look at one more code base. So this is a code base where I'm doing some kind of API testing. The previous code base that I showed you is a code base for Selenium, Cucumber Selenium, and it uses again Copilot and HyperExecute. This is primarily for behavior driven testing. So in this case, I'm looking at some kind of an API testing, and I can go here as well, and it's the same concept. I would like to go ahead and trigger a HyperExecute job from my local desktop, and I should be able to see the new jobs being triggered. And as you can see, it's been executing. This is a concurrent execution. It is where I've specified execution as 5. So this test is currently executing on 5 different kinds of infrastructure, and gradually I have a past run here, which maybe I can show you, and it shows what are the pre-steps, what are the post-steps, what are the scenarios, and what was actually done as part of the overall execution. And not just this, you do also have a lot of tools around analytics, why a particular test case failed, what is the overall trend in terms of the test cases, dashboarding, reporting. All these also automatically come to you. But as a developer who's developing a lot of features, we now don't have to worry about how do I set up my test environment, how do I configure that, is the infrastructure available to me all the time, and what if there's a change in the config. So we don't have to worry about all those things, provided we have the right set of configurations in place. HyperExecute automatically provisions those infrastructure on the fly, and the moment the test case gets executed, the infrastructure actually comes down, right? So you only are looking at or using the infrastructure only for the duration where you would need it only for the test case execution. And as you can see, I don't have to wait for an IT team to come and trigger the builds or something else to happen, right? I just committed the code. With the code commit, the GitHub workflow kicked in the GitHub workflow, then submitted the job to the HyperExecute, and the HyperExecute is also automatically to get started. So net, if you look at the development time or the time that a developer would need for the whole SDLC in terms of coding, in terms of unit testing, integration testing, automation testing. Pretty much the entire gamut can be covered and automated to such an extent that you do not need manual intervention at all, whether it's infrastructure provisioning for your test cases or configuration of your test cases, or even authoring of your test cases, because you have tools like Copilot which will actually help you to do that. So this is what I had in terms of demo, right? So I could see that probably the jobs would have also completed, and obviously there are ways and means in which you can integrate. So let's say there are bugs, you would want to integrate with your bug management system, and raise a bug depending on the particular issue that you see. You can take snapshots, you can record videos of the execution, and a lot more features to offer in terms of the overall platform. And it's very robust. And it is, I would say, the next gen test orchestration program that's out there in the market. So with that, I end my demo. Will be happy to take any questions. Please do connect offline as well in case you have any questions.
Hi, Karan. Thanks, Divya. Thanks, Karan. Just so as we are right on time, I will just quickly pick one to two Q&A questions. And so one of the question is, can you explain how GitHub solution align with the security and compliance needs of startup, especially when utilizing AI-driven tools?
I can take that question. So basically, when you look at the overall co-pilot initiative, right? This is a this the, when the code, actually the context that gets passed on from the agent to the model, that happens in a secure tunnel. Number one, and there's a lot of isolation when it comes to provisioning these resources for you in terms of an organization perspective, right? So as a platform provider, Microsoft and GitHub have come together to make sure that you have the utmost level of security and compliance in line. In fact, as I speak, in my current role, I talk to a lot of customers every single day. And as we speak, right, a lot of startups are already embracing this journey of Copilot. So with Copilot, certain things are covered. And when it comes to GitHub as a platform itself, right, you do have two versions, the enterprise version and the cloud version. And that's where your repositories are already hosted. But because of the fact that you have a level of isolation for your organization, which does not conflict with other organizations, you can be rest assured that security compliance, whether it's of your code, whether it's of your repository or your actions, is being taken care, right? So it works both ways, both for the GitHub platform as well as Copilot.
Definitely. Thank you, Divya. Uh, so all of the questions that are related to HyperExecute, we have tried to answer them, most of them in the comments, as well as we have also set up a booth table dedicated to HyperExecute in the launch table. So if you have any doubts or if you are curious how HyperExecute can help you reduce your test time, so please do join us on the table, and we will happy to give you a demo. On the closing remark, I will also like to just pull up one more question. Uh, this question was asked by Jayant. Could you provide examples of how HyperExecute enhances the testing process by utilizing the existing GitHub infrastructure?
Yeah, so you would not be using the GitHub infrastructure here. GitHub again will be an orchestration layer that will then submit your jobs to HyperExecute, right? So the test provisioning, the test execution, and the necessary resources that you would need for the execution of the resources will actually be done on the HyperExecute platform, right? Where you would use GitHub infrastructure is behind the scenes. Actually, it is behind the scenes for the user as well, right? Because we are using it as a SaaS platform. It's a software as a service platform, right, where it is meant for depending on the number of licenses that you get, these resources will already be provisioned for you. You will be using it only as a service. So you would need not worry about why or how GitHub manages the infrastructure. All that is done by GitHub for you.
Thank you, Divya. Thank you for guiding us through the intricacies of GitHub and HyperExecute and offering a dynamic blend of insights, practical examples, and a touch of fun. We hope everyone has gained a little bit more understanding of what these ecosystems can add to your current testing landscape. So, with that said, I will take the leave for the day. Happy testing and have a great day.
Thank
Thank
you
you.
so much. Thank you for having us.